So I know it's a stereotype example of swapping two numbers, but I'm going to stick to that because the functionality is not important. I want to discuss how do you use pointers? What is the advantage of using pointers? The value or the power of pointers. So this is my main. So I will have two integer a equal to 10, integer b equal to 20, right? Then I will say print a. So I'm writing a pseudocode. It's basically printf %da. You know that, right? Then I'll say print b. So once I do that, I'll write another function, void return type. Name of the function is swap, and it requires two integers, x and integer y, right? And you know the code of swapping two variables or swapping two numbers, right? We declare another variable, integer temp. We'll say temp equal to x. We want to swap x and y. X equal to y and y equal to temp. That's basically it. So we're swapping two numbers. I have two numbers, a and b, in my void main, right? I want to swap them. So I will call this swap function swap. I'll pass the parameters a and b, and now I'll assume that the swap function will do its magic and will swap the values a and b. So we'll again say print a, and we'll say printf %db, and I expect to print the value of a as 20 and b as 10 swapped values, right? That's what I expect. So this is my main, this is my swap function. I'm going to call the swap function here. This is my call. So now let's draw the stack and let's discuss what happens behind the scene. So this is my stack, right? Stack is used to store the local variables for functions, right? Now, program execution always begins from main. Fair enough? So we'll start from this line, integer a equal to 10. So it's a declaration plus initialization. So on stack, we'll create one variable. Remember, local variables are stored on stack. So a value is 10. It will have some address. Let's say 1000. B equal to 20. So another variable, local variable, b value 20. It will have some address too. Let's suppose 2000. Print a, print b. So we'll get output a is 10, b is 20. Now there's a call to the function swap. We are calling the function swap. You must remember from the last video when we discussed the function execution details, right? What happens when you call another function, right? So this becomes calling function, main is calling function, and this swap is your called function. What we do is we push the return address, right? So return address is the address of the next step. This is the next step after the function call. Printf this line. This line will also be stored in the code segment, right? You remember that from the last video? There's a code segment in the memory where your program code is stored line by line. So this line must be stored somewhere here, and that address, let's assume 8000. That address of this line will be pushed on to the stack because this is called as return address. That return address is the address of this line, which we assume 8000. It will be pushed on to the stack, right? Because when this function completes the execution, we need to begin from here. That's why we are storing that address before passing the execution control to this function. Once we push the address, return address, we pass the execution control to called function. So function execution comes here. First thing it has to do is it has to look at the function parameters. The swap function requires two parameters of type integer, right? So it will create that in the order right to left. So first y will be pushed onto the stack, created on the stack. Y has been assigned value in the call b. B's value is 20. So y value will be 20. This is passed by value. You are passing some values to the function argument. So y20, again this will have some address, 3000, let's say 4000, and then x is being assigned, passed as a is 10, so x is also created. Let's say this address is 5000. Now parameters are initialized, so we'll move to the function execution of swap. First line is another local variable temp. So again on stack, another local variable temp. Has it been initialized? No. So it will contain some garbage value. Let's say minus 420. Cool. Next line, temp equal to x. Value of x is assigned to temp. Value of x to temp. So temp becomes 10. Y, x equal to y. So y is assigned to x. Y value is assigned to x. So x becomes 20. Y equal to temp. So temp is assigned to y. Temp value is 10 assigned to y. So y becomes 10. All the statements in swap function are done. Before we can return to the calling function, we must pop out the local variables of swap, right? Because we want to access this return address. And in stack, this is our stack. In stack, it is last in, first out. So unless we pop these local variables out, we won't be able to access the return address. So before we transfer the execution to calling function using this, we need to clear off or pop off the local variables. So temp, x and y will be popped off. And now we have the return address. So using this return address, it will be popped off first. And using that address, the execution control will come back here. Right? So we'll again pop off this. And using that value, will come back, execution control of the program will come back here. Now, we'll execute this line. Printf %d a. What is the value of a? 10. So a 10. Next, printf %d b. What is the value of b? 20. So b 20. Did we manage to swap the two numbers, a and b? No. A is still 10, b is still 20. But we passed them, a and b, to the swap function, and swap function had the code to swap two numbers. But these two didn't get swapped. Why? Obviously, you understand that this is passed by value. Values of a and b were copied into local variables x and y for swap. And whatever happened was done on x and y. So x and y got swapped. But a and b remained as it is. It was like we made a copy of a and b and then executed the swap code on those copies of a and b. So original a and b remained as it is, as you can see on the stack. Sometimes we want to alter the state of arguments. We want to change the condition of the actual arguments that we are passing. In that case, pass by value will not work, because in pass by value, your values are copied into local variables, local parameters. And only those changes will be done on the local parameters, local values. Original variables will remain as it is. Obviously, we have a solution on this using pointers. So we are going to study pass by address. Instead of passing the variables, we are going to pass their addresses. So there was this student. His name was Pappu. Pappu was in love. He was in pure love. Love with this girl called as Katrina Kaif. He lost his heart, his everything basically to this girl, Katrina Kaif. But Katrina Kaif used to live in Mumbai. Pappu was in Pagalpur, right? Pappu dreamed of Katrina day and night. Dry and wet. He would not study, he would not play, he would not socialize, nothing, just Katrina, Katrina, Katrina. So Pappu's friends and his parents were worried about Pappu. So one day, one of his best friends, Pappu's best friend, Papi, what she did, she brought a statue of Katrina, a real wax statue, exact lookalike of Katrina. She gifted this, copy of Katrina to Pappu on his birthday. Pappu was so touched by this gesture. He touched Katrina's copy statue It was almost real. And that day onwards, Pappu's life changed, right? Pappu was more happy. Pappu was contained. Pappu was doing things, right? Pappu was, he kept this Katrina copy in his room all the time. He would not come out of the room. He would talk to her. He would walk to her. He would, all the things you can imagine. So things were going fine, right? But Pappu started expecting a child from this Katrina copy. But child won't come. The abs were as they were as when the Katrina arrived. Because Pappu had believed that he got Katrina. Nothing was happening. After some days, Pappu grew tired of this static Katrina. She won't, move, expand anything, right? So what was wrong with this? The wrong thing was Pappu got a copy of Katrina. Pappu did not get real Katrina. Pappu's friends used pass by value. So we will help Pappu. So we will not pass by value. We will not make a copies of actual arguments. We have a mechanism by which we can access the actual targets, right? So let's do that. So I will rewrite my main, right? Then I'll call swap, right? Hang on a second. I'm going to make a change here. And then I'll say again, printf %d a and printf %d b, and that's about it, right? So this is my main. Now I'm going to make a small change into the prototype of swap function. Instead of two integers, I'll change the parameter types of swap into int star x, int star y, right? We have seen this, we have learned this in the video about pointers, introduction to pointers. This declaration means that x is a special variable. It will store the address of some integer. Y, this star indicates that y is a special variable. It will store the address of some integer. That means swap requires addresses of two integers. It requires two integer addresses, right? So here in swap, in the call, when I'm calling the swap function, instead of passing a and b, I will pass address of a and address of b, because my swap function requires two parameters which are addresses of integers. Look at this declaration, right? So this is my call. So integer a equal to 10. So we'll create it on stack. Next, we are making a call to swap. Before we can pass the execution control to called function, we'll store the return address of this next statement. Now we can pass on the execution control to the called function swap. So execution control will come here. First, we need to create the parameters, local parameters. Now, what is the local parameter? X. What is the type of X? It is unsigned int. It stores the address of some integer, right? Parameters are created from right to left. So first y and then x. What is the value of y? What are we assigning? What are we passing as an argument for y? Address of b. So address of b. So let's give them some addresses. So address of a was 1000, b was 2000, this was 3000. See, remember, all these are memory locations. So they will each have some address, right? So now y is assigned address of b. So address of b is 2000. That will be assigned to y. Correct? Address of a will be copied into x. So x, address of a is 1000. So that will be copied into x. X itself will have some address. Let's say 5000. Once the parameters are copied, we'll move on with the execution. So execution will come here. Regarding Pappu and Katrina, what has changed? So 1 year earlier, a friend had gifted Pappu with the statue of Katrina, copy of Katrina. And then we all know what happened with that copy, right? What Pappu did. So now Pappu's situation worsened because Pappu was expecting things from this Katrina ka copy and things were not happening. So somebody, another friend of Pappu, who was also very concerned about Pappu and Katrina. So that friend somehow got the actual address of Katrina's house in Mumbai. And on Pappu's next birthday, he gave that address to Pappu. Now Pappu has the address of Katrina, right? Better than statue, some address. So what do you imagine? Yeah, Pappu went first train in the morning to Mumbai, outside Katrina's bungalow, outside address. But there's a problem. The friend only gave address to him. But how will Pappu access Katrina? Pappu is outside the house of Katrina. He got the address. He reached the address. There's a big gate. There's a security guard. Pappu doesn't want security guard. Pappu wants Katrina, right? So we need to modify our code a bit to be able to give Pappu the access of real value. So I'm going to add that thing. If I keep this code unchanged, it will actually end up swapping the addresses 1000 and 2000, which we don't want, right? So X and Y right now are storing what? X and Y right now are storing what? They are storing addresses. But what do we want to swap? We want to swap the values stored on those addresses. We don't want to swap addresses. We want to swap the values stored on these addresses stored by X and Y. So we need to access the values stored at address stored by X and Y. X and Y storing some addresses. We want to access those values, right? So we have an operator. Yes, we have that star operator, value at address operator. Remember from the first video. Same thing applies to Pappu. Katrina is a movie star. A lot of people know Katrina's address. But who can access Katrina at her address? Only stars. If you're a star, you can access Katrina. I mean, you can have the address and then you can access the house, obviously. That's what I meant. So Pappu needs the star. Pappu needs to become star. Now, for Pappu to become star, it will be too late, right? So rather, Pappu acquires what Arya Stark has, face-changing ability. And Pappu becomes a star. Pappu becomes Robert Downey Jr. or Iron Man, Mr. Stark, right? Without the robot suit, right? Just Mr. Tony Stark. Obviously, I will also advise Pappu to join a gym prior to that and, make sure that apart from the face, everything else of Pappu is also bit like Mr. Tony Stark, right? Otherwise, it will look funny. Upper part, Iron Stark, lower part, Rajpal Yadav. So we don't want that to happen, right? Similarly, in order to access the value at address stored by X and Y, we need a star. So we'll apply star X equal to star Y, and we'll say star Y equal to temp. So star, that is value at address, will give you the value. Once Pappu becomes star, Tony Stark, Robert Downey Jr., then Pappu can access the real value, right? Obviously. So now, let's run through this code. Pappu's story is happy. Pappu lives happily ever after now with his cat Katrina, right? But we have to move on. Here comes the execution. Integer temp. So temp will be created on the stack. It is not initialized, so it is some garbage value. Next step. Temp equal to star X. Star X is value at address stored by X. Address stored by X is 1000, right? Value at 1000. Value 1000. Here is 1000. Value at 1000 is 10. So that 10 is assigned to temp. So temp becomes 10. Next, value at address stored by X. Address stored by X is 1000. So value at 1000 equal to value at address stored by Y. Address stored by Y is 2000. Value at 2000 is 20. So this 20 will be assigned to value at address stored by X. Address stored by X is 1000. 1000 is here. So value at 1000 equal to value at address stored by Y 2000, that is 20. So this will become 20. Next, value at address stored by Y. Address stored by Y is 2000. Value at 2000. 2000, where is 2000? Here. Value at 2000 equal to temp. Temp is 10. So 10. Right? Function execution is over. All the statements are finished. That means execution must return to calling function, that is main. But before we do that, we will pop off the local variables. So temp, X and Y will be popped off the stack. Next, we'll pop off the return address to return to the next line of the calling function. Now, we'll print %d_a. What is the value of A? 20. So A is 20. Printf %d_b. What is the value of B? 10. So B is 10. So this time we managed to actually swap the values. Right, so this was passed by address. So this time we passed the parameters by address. We did not create a copy of it. We just copied the address. And once we had the address of the variables, we could change their state. We had the star operator through which you could access the value at the address, and that's why you could manipulate the values. So this is passed by address, and this is one of the applications of pointers.